And now let's proceed to semi-log models. And I would like to start with Log-Lin model. So Log-Lin model, this is a semi-log model in which only the dependent variable is logarithmic. And let's have a look at the example. So let's consider the following compound interest formula. So y as a function of, not a function, but y is equal to some constant value of y multiplied by 1 plus interest rate taken to the power of time. So this is how we calculate the compound interest on y, which we can express in the following way. So by taking the logarithm of both sides, we get the following expression. ln y is equal to ln y0 plus t time multiplied by the natural logarithm of 1 plus r. We can do some replacement. So instead of having ln y0, we can just replace it with beta 1 because ln y0, this is just a constant. And instead of having ln 1 plus r, we can also just replace it with a beta 2, right? Because this is another constant. R, this is the interest rate is constant, so 1 is definitely constant. So yes, this ln 1 plus r, this is a constant, so we can easily replace it with beta 2. Whereas t, this is the so-called time trend. I will come back to it in a second. But for now, I just want you to have a look at this equation. So this is a Log-Lin model because we can see that the dependent variable y is expressed as a logarithm, whereas the independent variable, which is the time trend, is expressed in a linear form. And the interpretation will be the following. So a one unit change in x is associated with the beta 2 multiplied by 100% change in y. So beta 2 is the semi-elasticity of y with respect to x. So let's go back to our previous example. So if t increases by 1 unit, right, or let's say by 1 year, y will change by beta 2 multiplied by 100%. So when you estimate a coefficient and you get that it is equal to, let's say, 0.4, in addition, you will need to multiply it by 100%, so you will get 40%, and this will be the change in y. So when we have the dependent variable expressed in logarithmic term and the independent variable expressed in a linear form, to make them comparable, the coefficient needs to be multiplied by 100%. And as I promised, I will discuss the time trend in a bit more detail. So this is the variable which is equal to the time index in a given year. So for example, if your sample includes years from 2015 till 2020, then time trend variable equals to 1 for the year of 2015, 2 for 2016, 3 for 2017, 4 for 2018, and so on and so forth. So this is how the time trend is constructed, right? So in our case, it will be equal to 1 for the first period, 2 for the second period, and so on and so forth. So we can say that ln y, each period changes by beta 2 multiplied by 100%.